Alright guys, now for number 6, it says the parametric equations of a curve are x is equal to ln 2 plus 3t and y is equal to t over 2 plus 3t. Okay, and it wants to show that the gradient of the curve is always positive. Right. So how do we go about this? Well, the way you could go about this is by saying the following. dy by dx, okay, gradient of the curve. Okay, so we have to show that dy by dx is always positive, right? And dy by dx is going to equal dy over dt. In fact, let me write it like this. Be easier to comprehend. Dy by dt times dt by dx, right? Because the dt's are going to cancel and you're going to be left with dy over dx. Okay? So, dy by dt is equal to what? Well, if we take a look at dy by dt, we're obviously going to have to use the quotient rule here. Okay, so looking at that, we can say, well, say 1, 2 plus 3t minus 3t over 2 plus t squared, okay, because 2 plus 3t we set to v. And that's going to give us 2 over 2 plus 3t squared. Meanwhile, dx by dt, well, what is x? X obviously equals ln 2 plus 3t, right? So therefore dx by dt is going to equal 1 over 2 plus 3t times 3, which gives you 3 over 2 plus 3t. Right, and as a result, dy by dx is going to give you 2 over 2 plus 3t squared times 2 plus 3t over 3, which is going to give me 2 over 3 2 plus 3t. Right? And I can say, well, look, that's dy by dx, right? And we've got dy by dx. Now, as x, what does x equal? Well, x equals ln 2 plus 3t, right? So as x equals ln 2 plus 3t, that implies that 2 plus 3t must be bigger than 0, because we can't ever go below, right? So if 2 plus 3t is bigger than 0, and dy by dx is equal to 2/3 of 1 over 2 plus 3t, therefore this is going to be greater than 0 always. Alright, so therefore dy by dx is greater than 0. Alright guys, for number B of this question, it says to find the equation of the tangent to the curve at the point where it intersects the y-axis. Okay? Right. Classic. So, intersecting the y-axis, what does that imply? Well, on the y-axis, x equals 0. Okay. On the y-axis, x equals 0. Okay, we know that. So then, what's that going to imply for us? Well, that means that ln 2 plus 3t is going to equal 0 as well. Okay. Right. So therefore, what does that tell us? Well, if ln 2 plus 3t is equal to 0, if we take ln of both sides, we know then that 2 plus 3t is going to equal 1, which means that 3t is equal to negative 1, which means that t is equal to negative a third. Okay, so therefore, if t equals negative a third, then dy by dx is going to equal what? 2 over 3. Okay, times 1 over 2 plus 3t. Okay. Which gives me what? Well, this is going to give me 2. That's going to give me a value of 2 over 3. Alright, and dy by dx is equal to 2 over 3. What's y going to equal? Well, at negative a third, y is going to equal two plus right, and that's just going to equal 2 plus 3. Okay, that's just going to equal negative a third. Okay, so therefore what we've got is the following. Remember, y1 minus y2 is equal to mx1 minus x2. Okay, that's our equation for the formula here. So y minus a third is going to equal 2 over 3 x minus 0. Okay, because remember, hit the y-axis. So therefore y plus a third is equal to 2 over 3x. Therefore y is equal to 2 over 3x minus a third. Okay, we've got that. And so what we can say from here is, well, that's basically the equation. You could put it in a different form if you want, but that's basically it. So just to recap here, okay? This is our equation. All we've done is we've recognized that on the y-axis x equals 0, okay? We found a value of t that suits this. I'm going to dy by dx, okay, we found that using the value of t. We got to here. And our answer is 2 over 3x minus a third.